This is Lab 9, Example 2. Given the parent function y equals f of x, determine the following. We are given a graph that looks like this. This is the parent function, y equals f of x. And we want to answer parts A and B. For part A, we want to answer what function is graphed below, and we are given this graph right here. So we want to figure out what has changed from the parent function to our function in A, and then write down what the function would be. So in our parent function, we have a circled point here and here that are essentially the same point but moved from our parent to our function in A that we're going to compare. And just looking at them, we see that unlike example 1, it has not simply moved left or right or up and down, it has also flipped in some way. There's been some kind of reflection, and we can actually just look at it and tell that it has flipped over the x-axis. So there's been a horizontal reflection, or a reflection about the x-axis. And if we look at our transformations over here, a reflection about the x-axis is in the pattern of y equals negative f of x with a negative outside our function. So we've had a reflection, the x-axis reflection, and that's in the pattern of y equals negative f of x. So next we're going to have to look at if it's had any shifts after this shift, after the reflection, and it turns out that yes, if we look at this point, negative 4, 6, if it was just had a negative in front of it, then this point would be negative 4 and negative 6 if we just flipped it over directly down. So I'm going to mark it on both. Negative 4, 6, 1, 2, 3, 4, 5, 6, 4. So if it was just a reflection about the x-axis, this point would then become this point. And the same thing here. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. So now to compare, we are going to decide if there was any vertical shifts or horizontal shifts. We already know that there was no stretches or compressions of any type because it's the same size. So we're going to compare this point to this point now. So after we flipped it over the x-axis, how has it shifted up or down, essentially? So we're going to compare this point, which is negative 4, negative 6. Let's write it there. Negative 4, negative 6. And it looks like we have moved horizontally from negative 4 to negative 7. So we've gone left. We've gone left 3 points. 1, 2, 3. So we've gone left 3. And we've gone upwards. So we've gone from negative 6 to negative 4. So we've gone up 2 spaces. Right? We've gone up. So we've gone up plus 2. So looking at our transformations again, we have our vertical up shifts, our vertical down shifts, our horizontal right shifts, our horizontal left shifts. We went left 3, so that was a horizontal left shift, is in the pattern of y equals f of x plus h in parentheses. So this is going to be in the pattern of y equals f of x in parentheses plus 3. And we've gone upwards 2, so that's a vertical up shift, so we've gone y equals f of x plus k. So this is in the pattern of y equals f of x plus 2. And we're going to put all of these things together. So we've had a negative from our f of x, we have moved left 3, and we've gone upwards of 2. So combining all of these three things, we know that our function that's graphed in graph A is y equals negative f of x plus 3 plus 2. So we've just sort of combined each of the things. This is the important part, this is the important part here, and this is the important part in each of these three shifts. So that's for part A. We can get rid of that graph there. For part B, we want to describe how the graph of y equals f of x minus 3 minus 2 can be determined from the parent y equals f of x, and then we want to graph this function right here. So doing the opposite of what we did in A. In A we had a graph and then we found the function. Here we are given a function and we want to graph it. So we have f of x minus 3 minus 2. We've seen this pattern before. We know that this right here is going to be going to the right. It's going to be going to the right 3 spaces. And we know that if it's outside the parentheses of our f of x function, if it's minus 2, it's going to be going down 2. And there's nothing else. There's no negatives anywhere. For example, there's no negative here. There's no negative inside. There's no compression or vertical thing that's being multiplied anywhere. So these are the only transformations that are taking place. We're going to take our parent function, we're going to move everything to the right 3 and then downwards 2. Just like we've done for the other ones. So now we're going to graph it. So we have our graph right here. So I'm going to mark out the parent function, and we're going to move each point in the parent function right 3 and then downwards 2. So in the parent function we had negative 4, positive 6. So that's negative 1, 2, 3, 4, up 6, 1, 2, 3, 4, 5, 6. So in the small dots, that's going to be the original. I'm going to mark down the original here. So we have, in this one, we have negative 2, negative 1, negative 2, negative 1, that's the original. Then we have negative 1, negative 1, positive 1, negative 1, excuse me. Then we have 1, 2, 3, 4, down 3, 1, 2, 3, 4, down 3. So we have these 4 points here. And we're going to move each of these points right 3 and downwards 2. So this is going to go to the right, 1, 2, 3, and then down 2. And that's going to be the transformed point of our new function. Same here, right 3, 1, 2, 3, down 2, 1, down 2. And then right 3, 1, 2, 3, down 2. So it looks like that one has changed. And then right 3, 1, 2, 3, down 2. And then we're going to connect all the big points. And there we have our transformed function.